There's a very natural idea that's at the heart of the process that I'm about to show you. And if you can remember this idea, you can do the whole process without any notes at all. So let's start with what you know about making a tangent line. If my red exponential function is called f, and if my tangent line is called p, in order to make the tangent line, you need to do two things. You need to set the two y coordinates equal, and you need to set the slopes equal. So in other words, f of 0 and p of 0 need to be the same, because that's the y coordinate of my curve and my line. And then f prime, which is the slope of the tangent line of the red curve, that needs to be the same as p prime, which is the slope of my blue line. So I know if I set those two things equal, it will produce a line that looks like this, with the same y coordinate and the same slope. And here it is, it's 1 plus x. Alright, so if you want to make this approximation better, if you want to make it a second degree polynomial, you just continue the same trend. Instead of just setting f and p equal and f prime and p prime equal, you would set f double prime and p double prime equal. Well, why does that make sense? So here, the reason that my blue line isn't following the red curve very well is because the red curve is curving up. In other words, its tangent line slope is increasing as x gets larger. That's why it's concave up. So what I need to do is I need the concavity for my approximation to match the concavity for the red curve. So that's exactly what you're doing when you're setting the second derivatives equal. I'm saying that the rate of change of slope needs to be the same for both functions. If I wanted to make a cubic function, I could just continue the trend. I would say, in addition to having the concavity be the same, let's set the rate of change of concavity to be the same. So now my polynomial approximation's third derivative should be the same as the third derivative of my original function. And you can continue this process as far as you'd like. Well, you may be noticing that as I'm gesturing over here, mysteriously I'm getting these polynomial approximations down here. And that's what I'm just about to show you. I'm just about to show you how you can go from this idea of setting derivatives equal and end up with all of these coefficients that you need in front of your polynomial.